This is your boy Nick Nat, back again with another video. In today's video I will show you guys one of the many ways or purposes I use excess energy, and it's on days when the voltage normally peaks at 13.6 volts, and that's normally on between 10 p.m. and 1 p.m. Central African time. So let's get out of this wonderful sun and go and check the system out. And we're back. So one of the uses I use excess energy for, so it doesn't go to waste, it's basically charging up this 35 ampere battery. It's by Rhino Power. Normally I have this hooked up to this multimeter sitting right here, and now the voltage is about 13.56, but I normally hook it up say from 13.5. Depends on how many items I still need to charge for the day, but the vast majority of the time I'm gonna make use of good energy like that. And what I have is the current setup for how I normally go about it. Normally I don't have the separate multimeter hooked up in series to check out what the ampere flow is in volts between the 105 amp deep cycle battery of Rhino Power and then the sealed lead as a deep cycle battery. It's just for illustration purposes, and normally I have a 7.5 amp fuse in series where this multimeter is hooked up to those terminals. So let me have it quickly set up. So I have it set up. Remember, this multimeter is in series between this battery and that battery, and then the purpose of this multimeter is just to take the voltage of this battery. So we're seeing 12.6 volts on this battery currently and 13.3 volts on this multimeter, reading the voltage of this battery. So let's see what happens when we make the connection. So there we see there's a jump in voltage. The amp drawn between the 35 ampere and the 105 amp battery, it's 910 milliamps, and as the voltage climbs on the 35 ampere, the current drops down. I haven't really checked out to see at what voltage the ampere actually stabilizes, if you can call it that, or rests, or if we can call it equalize. I don't think that would be the proper term, but I'm sure you guys get the idea. And yeah, that's what I basically do for two main benefits: making sure that excess energy don't go to waste, that being the main first benefit, and then number two, extending the life of this 35 ampere. I do have a similar setup between this battery, the 7.2 ampere, and another setup. I think I should, hopefully by next week, if everything goes according to plan, show you guys the other setup that I strictly just have for lights and two pink LED lights. It's a bit modified for the bathroom for my young niece. Normally when it's time to go to the potty, then she doesn't have to switch on the main light, which does affect the sleep pattern. It's very kind to the eyes, but that should hopefully be by next week. Oh, I love looking at these numbers, 1300 down there and 1320 up there. So that's about 0.20 volt difference between the voltage of this battery and that battery. I thank you for watching till the end. See you guys in the next one.